Use the graph of the function f to decide whether the value of the given quantity exists. If it does, find it. If it does not, enter D and E. So we have a very interesting graph here, and we have to answer various questions. So part A wants f of 1. That's basically asking for the y value when x is equal to 1. So if we look at the graph and we go over to x equals 1, which apparently is right about here, the y value appears to be 4. There's a couple holes here, but we want the solid dot. So in this case, the y value is 4. Now we want the limit as x approaches 1. So when we compute the limit, what we'll do is we'll approach from the left and from the right. If we get the same answer, then that's the answer. If we get different answers, then the limit does not exist. So let's see. As we approach from the left, it looks like the y value is approaching 6, right? We're approaching x equals 1 from the left, the y value approaches 6. When we approach 1 from the right, the y value looks like it approaches 1. Okay, so from the left, we get 6. From the right, we get 1. These are not the same, therefore the limit does not exist. F of 6 is the y value when x is equal to 6. So if we go over to 6 here, you'll notice there's actually a hole in the y value. There is no solid dot anywhere. So in this case, f of 6 is undefined. The problem wants us to enter D and E, so we'll enter D and E. So again, there's a hole. If it was filled in, then the answer would be 4, but it's not, so it's D and E. Now we have to compute the limit as x approaches 6. Well, as before, we'll approach from the left and from the right. So from the left, as x approaches 6, the y value approaches 4. So even though there's a hole, we don't care about what happens at x equals 6. We only care about what happens when we're close to it. So from the left, we get 4. Likewise, from the right, you can see we also get 4. Therefore, the limit is equal to 4. So in this case, it's 4. So the limit can exist, but the function is not necessarily defined there. That's what this shows, right? You can have the limit exist, but the function here is not defined. And here, you can have the function be defined and then the limit not exist. So it's kind of an interesting example because it shows that. I hope this video has been helpful. That's it.